Cool, thank you. So we'll do the tour for bringing up Docker containers against our Docker admin using OpenCrowbar. And I already have the Docker admin running. So what I did to start all this stuff was I ran the Docker admin. I've already done that stuff. It's really not that exciting. What it does is it starts with a base CentOS 6.5 container that we've installed all the prereqs for. So the Postgres 9.3 server, Ruby 2, the Rails, a lot of the gems, all the prereqs are sort of built into the container because we don't want to have to deal with them every time. But none of the Crowbar stuff is in. So when you start this container, the admin node container, it literally goes through a regular Crowbar install using the code that I checked out external. So the first thing we do is we mount our working directory into the container, and then the container installs from that mounted share. And then, so it's actually just as if you installed an RPM and then ran through the full install, even down to installing the database. And then in this one, it uses a script to actually hit the APIs to create the admin node. And then when it's done, it gets the Crowbar converge. That is the end. And now I've got the Crowbar system. So this is all the node roles that are deployed in by the annealer, which look over here like this. And so what you've got is this admin node has deployed all of the roles necessary to run Crowbar admin. It actually has this no op role, this milestone role. It doesn't do anything, but we use it as a breakpoint. So we found it's really helpful to have these coalescing points. They don't do anything, but the work ties to them. And that's really important because of the way we had to deal with Docker. And I'll tell you, Docker really, I'm about to start up a VM just to have a VM in the system. So Docker turned out to be a really tricky thing to implement because it's fundamentally different than VMs. VMs are really convenient. Oops, hold on. I can't, I don't want to start. I didn't reset that VM when I rebooted the machine, so let me actually wipe it out. Restore it back. Crowbar sets it to not pixie boot the second time, so I have to actually tell it to pixie boot. So VMs are like physical machines, right? They're gonna pixie boot. I'm gonna have a network in them. I'm gonna have control of the OS. So every single thing inside of the VM is basically mine to control. All I really have to do to automate VMs is talk to the API and say, give me a machine based on this disk image, and it goes. And then I can do whatever I want. I can bond the NICs, I can do teaming, I can set the DNS entries, I can set my my bind records. I have a lot of control inside of a container, and I can install an OS. I have to install an OS. If I do it with a container, I don't have that flexibility. And what happens is that of the roles that I can actually do to bring up, that they'll actually set up once this node finishes booting, it'll go through and start annealing, setting up the clients, setting up a whole bunch of these pieces. The containers don't need to do most of that stuff. It's already baked in based on your host configuration. So bringing up Docker slaves requires your host to have a degree of configuration that works within the system boundaries. And then even more tricky is it requires you to have two paths through your configuration deployment infrastructure. And so what that means is we have to create this new concept in Crowbar. So the idea here is every one of these things is a role that has to be set up for you to be successful with a boot. And there's a role in here called Crowbar Managed Node that is installed when Crowbar reaches. It's a no-op milestone role. There's also one for installed OS. So we'll boot, the discovery boot also goes all the way through Managed Node because that's the point at which you can control it. Installed OS takes it, reboots it, and puts the OS on it and repeats all the steps again. You don't have to do either of those things with Docker. So it just finished booting over here, so it's about to start doing the discovery steps. There it goes. So what you'll see here is I've just booted this node. I have to put DNS entries in here so that I can talk to it, and then I'm going to go through the rest of the process. And what's fun with the annealer is there's some things that you have to do on both regular nodes and admin nodes. I keep trying to fix this scroller. It always takes me a couple iterations to get it right. And then there's things that you don't do on, depending on the type of node. Like the logging client is only necessary on the nodes, is not necessary on the admin. And so you can go through and see all those things working. Oh, but you'd be interested in this. We did finally get, let me fix this. We did finally get the heterogeneous OS in one of the other videos I've shown, picking the OS and choosing and letting it boot into a different OS. But these little wrenches show that you have proposals, and in the proposals you could actually, if there were configurable items, most of the discovery stuff doesn't have configurable items. You could actually go in and mess with it. That's something I show in another video where you actually pick the OS. But what's going on right here is we're literally moving through. It's installed the Chef agent on this machine. It's actually put the NICs in the right modes. It's setting up the network, the admin network right now, and it's just going to keep happily blowing through each one of those. The other thing that's really fun is because the way we're using Chef Solo, these are the logs of each run. So when you come back and look at the system, you're going to see this run's not done yet. So just about to finish. You can see it actually getting notifications as it completes the work. So you can actually drill down and see exactly what happened on that node and how things are going and what happened. And if there's a problem, you can fix the error and hit retry and get some new data. And here's all the IPv6 stuff we set up. So it sets up IPv6 by default. Oh, the other thing you'd be interested to see. This is the new version of network.json. So if I want a new network, I can set up my new network. I can attach it to a default so the network is in a scoped boundary based on deployments. Set up IPv6 for me. This is going to be 1G1 and add the network. And then in here, you can actually go through. I think we're cleaning this screen up a little bit, but you can set the team, bridge, all this stuff, and then add in whatever ranges you want. And it basically is building the same stuff we've always done with network.json, but you now can change it dynamically. And since we use IPv6 as the preferred mechanism, it's much less problematic for Crowbar to change the IPv4 ranges, which is all fun. All right, so to Docker. Let's see, so nodes. This guy, the green check means he's done. Let's see. Yeah. All right. So let's bring up some Docker nodes. So here's the way, and this is from saying, all right, this is Ubuntu. Not sure which Ubuntu we use in the slaves. We'll find out in just a minute. So what we've done here is there's a tools Docker slaves, and then you just provide how many slaves you want. Victor's testing with 100 to flush out lock contention issues and scale issues. I don't have enough RAM to do that. 6 is usually, my machines are RAM constrained enough that at 6 I'll start to get some failures. So I hit enter, and what it's doing is it's using tmux, which is like screen, to bring up all of the containers. So I'm gonna have to find another, yet another. All right, so black background is my admin container. Purple background is my 6 Docker containers, Docker slaves, and blue is going to be my original dev environment. So if I say Docker PS, that's strange. Oh, it takes time. So one of the things to note in this is that each one of these guys the scripts do not create the Docker containers. Crowbar creates the Docker containers. The scripts use the API, use Crowbar's API, and tell Crowbar. So what we did was, when in the Crowbar API where you create a node, it's not a single action. We broke it into pieces. So you create a node, and then you actually go and assign the role that you want that node to take. So in this case, in a discovery node, you say, oh, I want to be a Crowbar managed node. And that tells it to bring up a regular discovery process, and Sledgehammer has all that baked into it. The Docker slave script doesn't. It says create a node for me, but use the Crowbar Docker node role. And that actually has a different dependency chain and installs different roles, and Crowbar knows how to handle that milestone role differently than the Crowbar managed node role. But they are both equivalent. So there's a concept that we introduced called provides, where you can say, all right, if I'm gonna assign Crowbar Docker roles to this node, and the system is going to treat it as if it was a Crowbar managed node. Actually, I think a Crowbar installed OS role. And that lets us have different system behaviors, different role graphs, but downstream from that, treat it exactly the same. So if I want to build deployment automation against OpenStack or Hadoop or Ceph or something like that, and I want to test with Docker, I just build the automation as if it needed installed OS role, and then when I bring up the Docker admins, the Docker roles for test, it's going to say, oh, well, these could do the same thing. It's like an alias. They provide the same capability, and then you can do your test dev deployment in an environment where, and you can see my machine is lagging from the load of bringing up all these machines. I'm bringing up 6 nodes. I could do a 6-node deployment, and it's going to take me about 3 minutes start to finish. It took me 3 minutes just to get through the discovery process for a single node, and I haven't even installed the OS. I can tell you when I installed the OS on this VM, it's going to take another 10 minutes to complete. And this is a machine with 16 gigs of RAM, so it's a huge advantage to be able to do these multi-node deployments using a container. And literally right here, I'm in Mux, so I can Control N, jump to the different containers. So here's the first container. We had been playing with the release version, so let's see what the release that we have is. So in this case, we're using 1204 again. And what we haven't done yet, but it's not that hard, is allow you to choose the container image that you want to add in when you do this. It's this, even making Crowbar, which is pretty well suited to Docker, it took us 6 months to get to this point of being able to do it, because we had to be able to have the APIs split so that you could control how a node is created. That actually was a pretty significant piece of work. And then the whole idea of this provides role, where you have different chains of role definition, was also another piece. Because if you look at the graph that we're setting up here, there's a whole bunch of roles that are essential for a VM or a physical node that you just don't even need. And so we had to have an infrastructure that could deal with the fact that these are very different workflows at the system deployment level, but then would be identical workflows at the application deployment level. And that's a big part of what this ends up being. Yeah.
Quick question. Why does like a Docker container not need a logging client?
It probably could use a logging client. That would be something we could add. For now, we've kept them pretty minimal from a test deployment perspective. And to add it, you would just make the logging client a prerequisite for one of these other roles, and it would just throw it in. The thing that it really doesn't like to have is it doesn't like to have you bind DNS clients. There's certain things that you're not allowed to do. The NTP isn't necessary in here. That you can't Pixie boot, a Docker container. The
Right.
concept,
Yeah.
does this make sense? Um, yeah, and that was one of the things. Crowbar, Crowbar one especially relied on Pixie as the discovery mechanism. Most of the
Right.
tools out there do, right? Razor, Cobbler, Foreman's. Yeah, it does actually rely on Pixie boot to get images in place. If you take Pixie boot away as an image deployment thing, you're actually going to have trouble finding an alternate way to get that image on, especially when you're not actually installing the image. You're running a command that creates that image. There are some people who are doing like a libdocker to try and create some substitute. um, what we're doing with Crowbar is different. We're focused on building the infrastructure that goes under Docker. So if you want to have teamed NICs to support your container and then plumb your Docker bridge to those team NICs, that's where we're focused, right? It's the under plumbing of this. And then if whatever Docker management infrastructure you want to add, which would be like a Cloud Foundry or an OpenShift PaaS, you add that, you install that layer and let it manage the containers coming and going. That's their job. Um, it actually ends up being a pretty clean separation. And so, um,
So from this perspective, though, you're not necessarily managing the content of the Docker container.
not yet, but we could. That's the goal. So what we would do is we'd create a new deployment here, and then let's see, come in. I'll bulk edit them so they go through. And we haven't worked yet to optimize workflows for Crowbar. A lot of these things are still using pretty basic workflows. Okay, good. And then so I can come into my default deployment over here, and I could add in say Ceph. And then what would happen is now I'd actually be deploying my workload. Ceph isn't going to work for me, right? It's interesting. I need to figure out what. Yeah, we don't have the workload yet for me to demo what you would install in Docker. But the idea is pretty straightforward. You would take an application and then you would bind it. Clicking these buttons binds the application in to the Docker node, and then when you commit the deployment, let me build a new deployment. I'll show you what it looks like from an OS perspective. All right, so let me add a VM. Oops, VM. All right, I'm gonna go ahead and install the OS on this one, and let me add in this guy's my actual VM. Cool. One of the things that you'll notice I didn't point out is the networks are also roles. So network configuration is part of the graph. Oh,
Yeah.
Ceph. I couldn't deploy Ceph because I didn't have a Ceph network. I'm such a dingbat. So Ceph actually requires a Ceph role in the system. So I need to have a role named Ceph, a network named Ceph to create the Ceph role, and it has to be in the appropriate scope boundary, which is this deployment. And I can call it 1G1. That's fine. So when I add this network and I come back over to default, I should be able to apply the Ceph. Yeah, there you go. See, I haven't had time yet to give the round trip Ajax feedback on errors yet. But so by doing this, I'm literally binding the Ceph network and Ceph config into the environment. When I hit commit in here, it actually goes and starts the annealer. So you get this is the work queue of what's going on.
Okay.
So I can see anything that's an error. The things that there's 10 worker nodes. We're using delayed job. Whoops, and it's already done because it didn't have much to do. And so it literally goes in, does transition to do items or things that could be done, but we just don't. They're blocked based on the way we execute work. They're not really blocked. They could be done, but other things are in transition. And blocked items have a upstream node role that is in to do, if that makes sense. Uh, right. And then a lot of this stuff is pretty familiar. Oh, you can actually see I didn't create an IPv4 address space. I only created IPv6 address space, but that's okay. Right, so it's going to say not set because there's no IPv4 address. If I come over here and I do an IPA, what you'll see is, yeah, see, this is it put the admin address in here, and then it's also created the IPv6 addresses that it's going to use. And you can see that if I click over I'm in Docker 4. So this is the admin address that we've installed, and so you've got both the IPv6 address and the IPv4 address that we assigned it. And then since Chef is also installed in here, let's see, should be installed. No, I don't think we haven't done anything that requires Chef yet. I can tell you. Yep, so the Chef agent's installed. So we've actually installed the Chef agent in here. Should be able to just run. I don't know why I'm not able to run Chef. Unless it's solo.
Is it Chef or Chef Solo?
It's Chef Solo, yeah.
Yeah.
So yeah, literally the systems come in and it's set up Chef Solo, and then whenever we're still we don't have to, but we have so much working code in Chef that we just ported all the configuration and setup into Chef Solo. But there's no Chef server with this. We just execute the code that needs to be executed. We SCP it in and do the execution. So if you wanted to turn Crowbar off, you just turn it off, walk away, and it doesn't need to. It doesn't need to stay embedded in the environment. There's no agent overhead from that perspective. Sort of like Ansible.
So are you doing statusing now?
I'm sorry?
Like Crowbar 1? Are you still doing statusing and stuff like that Crowbar 1 used to do?
Not to the same extent, no. We do have to have the systems on, and we'll check them and ping them before we take action on it. But the idea would be that we could actually use Nagios, or some other external system to do on/off if we need it. What'll happen is if the system is powered off, the annealer will fail at that one step, and then we'll actually have it blocked. And you'll see that actually very clearly. And that's one of the nice things, right? Anything that goes wrong in the annealer, you end up with very quick feedback that there's something that's happened. Oh, I was going to actually do the VM deployment over here. I added, so OS installed. This is what it would look like to actually set the OS. It's set by default to CentOS. I'll switch it to Ubuntu. And it automatically builds these Pixie images. So you install the ISO, you provide the ISO, and for Red Hat, Ubuntu, or CentOS, we automatically convert that into a bootable Pixie image. So it's really straightforward to have multiple OSs. And then if I go back to this deployment, I'm in proposed mode, so I can do editing. I can commit here. This is always fun to watch. It's fun in Crowbar 1. It's even more fun in Crowbar 2 because you can see the annealer. So it's going to come over here, and in a second it'll reboot. Yep, there you go. Reboots the system.
So basically that was sitting in a Sledgehammer image.
Exactly. No, this is what's cool. So Sledgehammer used to have that polling loop, but because we're using SSH, we don't have to do that. So
yeah, well, but you still booted into a RAM only image.
We still booted into Sledgehammer image, right? And you do get it away. Right. Yeah. Although with the ability to do jigs in worker queues out of band, we're switching to use iDRAC direct APIs instead of having to run them in that weird loop through the Sledgehammer image. So with that, we could actually power systems down because the iDRAC is still addressable even with the system powered down.
Yeah. Assuming you have a reasonably advanced IPMI system, right, or
Right.
BMC system.
Right. There's a interesting loop that we can do with iDRAC discovery, where it would actually, you can set up a DHCP server that tells the iDRAC to hit this web server, and it gets its credentials from that web server. It's a secure sort of loop, and it'll do that process when the server is plugged in, even before it's powered on. So we have the ability to take a rack, a discovered rack, have the power on, servers off, and actually have Crowbar discover them. And because we don't rely on the sledgehammer to actually be running to create the APIs, you actually create the systems, and you could then go and say, oh, I want these to be. You could do all sorts of configuration from the deployment screen before it's ever booted, and then the iDRAC jig would push the configurations to the system and then boot it, and then install the OS. Or you could avoid a PXE altogether by using the iDRAC OS mounting, ISO mounting, and install without ever needing a PXE. There's some really cool potential things because of the way the out-of-band stuff is structured.
Yeah.
And then so, the thing I was focusing on it's so fun. There's so much cool, fun stuff. But the Docker nodes are basically in here, and because I have this screen going, I can jump back and forth to different things. And if I wanted to experiment with my configuration, so I'm deploying OpenStack against 6 nodes, and I wanted to bounce back and forth, I could. My machine's going to get really slow with all this going on it. I could go back and say, here's Docker 1. Let me grab its IP address. 82, good. So I could SSH root at, I always pick up the 64. So I can always do what I expected to do. And this is a little bit mind blowing. I am in a CentOS Docker container on my dev machine, SSHing into an Ubuntu container running on my same machine, and so I could let's see. We need to be in the right path to make this easy. I can touch foo.txt over here, and then of course if I'm get back to my Docker container number 1 over here. There's my foo.txt, right? It's the same. It's I'm just SSH'd into the machine, but now if I'm actually troubleshooting and working on deployment and trying to get everything right, one, I have a 6-node system without 6 VMs, which even on our 32 gigs of RAM laptops is pretty onerous and heavy to do. But I set up a 6-node system in a couple of minutes, less than that. And then I have really super easy access to the consoles of all those systems. So if I'm looking at why something's failing or trying to make it work, I can actually be pretty effective trying to look at configurations and try and fix things and make it all work. And then even more fun from that perspective, let's see, this is also cool. So if I go into core, so I touch bar.txt this time. This guy, I'm back to my admin node. Let me exit. Now I'm back to my admin node. So I cd opt OpenCrowbar core, and you will see, where did I put it? Core bar text. Oh, sorry, this is a different machine. This is my. You gotta actually be in the right. You got to be in the right system. Make this stuff work. This one. I've got too many windows open. Let me open yet another window. All right. So back over here, if I touch bar.txt, okay, so I'm in opt. This is the normal install path, and then over here, Oh, my poor machine is crawling. So I'm about to wrap up the demo. Did you have any other questions before I sign off on the demo?
No, this is very cool.
Let's see, where's bar? Oh, I didn't switch into core. There we go. So here's bar.text. So if I make changes, so if I go into chef, oh, sorry, cookbooks, and so if I was to go into some, oh, and we added Burks, which is really cool. So Burks lets us pull code in from repos, so that every time when you run the code, you can actually have very fine-grained control over which cookbooks you use to do the deployments. It's not all bundled into Crowbar anymore. That was a recent change. But if I come into the network, say, let's see, this isn't a good example because it's core. But if I go into the recipes here and start messing, if I change the default recipe here, the switch config recipe here, the next time it runs that node roll, it actually picks that change up right away. So you don't have to upload it or anything like that. I'm editing in my dev environment. Remember, we used to have people doing all this weird SCP stuff all around, and it was really weird to get your code into the admin node. Because the thing is directly mapped, if I change the cookbook in my dev environment, the next time it runs that cookbook, it actually gets the code immediately. So there's no upload or sync or anything like that. You write code, you save it, you retry the node roll, and it runs the code. So between all these Docker containers and some of the ways, and this is an aspect of Docker containers being able to do this fast mounting. We've really tried to optimize the DevOps development experience, if you